How do you run?
How do you check
What
this?
do you run to get this?
To check the homoscedasticity
No.
or the VIF? I'll show you where it is. Good, that's a good
Okay.
question. Yeah. When we, in fact, in just a second, when we check this one,
Okay.
I'll show you where the button is. Okay, so to check this one, and we'll do it together in just a minute, we're gonna ask for a plot, and we want the Z residual plotted with the Z predicted. Okay? So it's just like it sounds. We talked about Z scores, right? Those are our standard scores. So we're gonna plot our Z scores of our residual or our error or whatever's left over out of salary that we did not explain, our residuals, with the Z scores of our predicted values. Okay, so whenever we run this, SPSS is gonna use the least squared method, and if we were in this for a whole semester, I would show you how to figure it out by hand. It's pretty neat actually, but when it combines all of these, it'll give you a predicted salary, and so we call that, if this is Y, this is your dependent variable, your predicted value is Y hat. And so this is the predicted salary. All right? So however far off we are from what we predict to reality, that's our error. Okay? So how good of a prediction do we have? Well, it's going to be the difference. So the residual is here. So it actually computes this predicted score for every single person. So he has, what, 231 participants' data. So he'll have a predicted, you can ask for it when you run it if you're interested, but you'll get a variable, that predicted salary variable, and how far the predicted is from the actual salary will be your residual or your error. So these are the Z scores of your errors or your residuals. Yeah.
No.
Okay. Along with the Z scores of your predicted values. So that would be these. So we're gonna get a plot of those.
I might be jumping ahead, but can I just ask this? I'm trying to put it together.
Yeah.
In the book, it talks about, I think it's called the DF fit. Is that the in-between that you're talking about? The predicting?
Yep, because that would be an indication of how well your data fits the model.
Okay,
Yep.
and then whenever we're running the plot, I know it said like you can run the Z resid and the Z predicting, then it said you can hit where it does all of them. We just need to do that one. We don't need to run it against all of them.
No, we don't. Just that one, yep.
Thank you.
Good question. Yeah, and all they mean by model is, you, the researcher, says these variables are good predictors of salary. So for you guys, whatever it is you're trying to predict, you say, you know what, it's these three variables are going to predict this. Now, how well does your data conform to what you're saying? How good is your model? So that's what we're looking for that model fit. How much can we minimize the difference between what we predict and what reality is? And once we have that, and it'll be a formula, you can use that formula in the future. So for whatever, if you're we have done some examples with kindergarten readiness. What variables predict students who will be successful in kindergarten? Well, it's this set body of variables. If they come in having gone to preschool, or their parents' education level, or all these other things that predict kindergarten readiness or success in kindergarten, then we could take that formula that SPSS would generate for us and use it to predict other incoming preschoolers' performance in kindergarten, or whatever, and whatever suits you guys, something along those lines. Okay, so we use it for explanation, but then also prediction. So the next time you open a preschool, then that will be very valuable to you. Alright.
Will you show us how to run that?
Yep. And I'm gonna show you the VIF where that button is. Let me just go through the last couple, and then I think it'd be easier to just run it all at the same time rather than go back and forth and back and forth. So that 7th one, the independent errors. We're gonna look at Durbin Watson. It's a value we're gonna ask for. And we want it to be, we want between 1 and 3. So the way to think about what that means, independent errors, is each one of these variables, unless there's a one-to-one correspondence with salary, we're gonna have error of prediction for each one of these variables. Well, that's okay, we just don't want those errors to be correlated, because that would indicate there may be something we're missing, like variables that are too highly correlated, because the errors would be too similar. So we want just a completely random spread of errors, just to show that these predictors are not kind of masking something. There may be some suppression going on or some other issues, but we just want those errors to be completely random. Right. And we also want the errors to be normally distributed. Okay, and for that, we're gonna ask for a histogram of your Z residuals. Okay. And the last one is linearity. So multiple regression falls under the general linear model, and all that means is we can only kind of pick up on linear relationships. So we have to make sure and check, are our predictors at least relatively linear related to salary? Because if there's another kind of relationship going on, something curvilinear, you know, maybe something where they peak and then go back down, multiple regression is the wrong analysis for us. So we just want to do a quick little eyeball check of some plots that we'll ask for, just to see, do we have a reasonable expectation of linearity? All right, so we're gonna write it up here because I know it's hard to see down there. We're gonna ask for a plot between the dependent variable and each predictor.
Of a model, it would be that, wouldn't it? I mean,
Yeah.
it goes up and then when they hit 30.
Right, yeah, it might be. So we'll have to make sure and look at that and see. All right, so kind of keep those notes side by side and we'll start going through. We've already checked that first one in SPSS, but for the other ones, we need to actually run the multiple regression to be able to check them. All right, so starting with 6, and then 7, 8, and 9, we'll have to run it. So we'll go to Analyze. Luckily, it's nicely named for us, Regression. All right, and you can kind of see what I'm talking about. There are so many different types of regression you can use. We're going to use linear. Linear. All right, so what was our dependent variable?
Salary.
Yep. and our independents are those other three. Right? Now, I'm just gonna show you this, but if we wanted to use one of those other methods, we could do that. Enter just means we're putting it all in there at once, which is the type of regression we're gonna use. But you could do the stepwise, remove, backward, forward, and that's where you would go in and say, you know what, SPSS, I want you to look at age first, and then number of years, and then attractiveness, or vice versa, or age and attractiveness first, and then number of, so, and that's all research design based. That's all up to you as a researcher, based on your reading and your understanding of your phenomenon of interest.
Can I just ask if the person that created SPSS is a billionaire? Like,
Yeah. Well, who owns it now? IBM? Massive company. Okay. So we're gonna go through and check some stuff for our assumptions. But remember, you can, if you forget something, and sometimes I do for sure, you can always go back and run it again and ask for whatever it is we forgot. We're gonna try to capture all those assumptions in one run. Besides multicollinearity, because we already checked that. We're gonna look for that VIF button, see if we can find it. All right, homoscedasticity. I know I need a plot, so I'm gonna come up here to my plot button. There it is. And just using your notes, which one should we click over? Yeah, there, and it doesn't matter which one you put where, because it's gonna plot, it's gonna be in a different section of the plot, but it doesn't matter. Here is a plot of my residuals. Where do I remember writing that?
8, normally distributed.
Right? A histogram of Z residual, and that's saying the same thing. My standardized, which would be the Z part, residual plot, histogram. There it is. So that's number 6 and number 8. Okay, independent errors. I need to find Durbin-Watson, so I'm gonna say continue here. Let's see what's under options. Nothing useful. What about statistics? Oh, there's Durbin-Watson. Good. Now here are the collinearity diagnostics. It's not labeled as VIF, but if you don't want to use the greater than 0.8 for that number 5 assumption, you can click collinearity diagnostics.
You say that again, if you don't wanna.
If you don't want to use if you don't want to run the Pearson correlations and check for correlations greater than 0.8, you can click on collinearity diagnostics and look for values greater than 10.
So we can do number 5 in the same
Yep,
situation.
if you prefer that. We always want descriptives, because we know that's part of a good write-up is to include those descriptives. All right. Now there's nothing else that we have to have.
What does the model fit do?
That is going to tell you whether or not your model is statistically significant.
Okay.
All right. So.
Or save, because I remember there was a lot of stuff under save. Did we need any of that?
You certainly could. Like here are those predicted values I was telling you about. So you can save them as raw scores. So that would be the difference between the salary and the predicted salary. It would save a column in my data set of those predicted values. You can save them unstandardized, so it would just be a raw salary value, or I could standardize them and they would come out as Z scores. If you wanted them. Same thing for residuals. If you wanted to take a look at the amount of error each time, you could get a column and it would give you that information. Haven't ever used any of the influence statistics. We read about Mahalanobis distance. That is some sort of multivariate effect size. I haven't used it in a long time. I'd have to go back and read them. And the other